Today we are starting ordering rational numbers. Remember, rational is just our way of saying all the numbers that I can write as a fraction, where numerator and denominator are integers, of course, right? And but these also include decimals. So I'm looking at decimals and fractions today. And today I just want to order. I guess we could start with some decimals and then we'll try some fractions, okay? So, if I want to order them, I'm just going to give you a list of a whole bunch. Oh, you know what? Maybe, well, okay, we won't mix them yet. We'll just do decimals first. I'm going to give you a bunch of decimals. And I want to put these in order from least to greatest. All right, let's say I just had these. I want to add one more. Do I want to? Yes, I do want to add one more. I want to add this one. Okay, so I have these decimals. I want to order them from least to greatest. Okay? I'm going to give you some strategies here. First of all, in this situation, all of my numbers are positive. If I ever had a situation where some numbers in my list were negative, right away, wouldn't I know that those negative ones have to be smaller than the positive ones? Yeah, so that's helpful if I ever have positives and negatives. I would automatically already know all the negatives would come first and then the positives. Of course, I'd have to figure them out in their in the right orders, but at least I would have somewhere to start. Okay? Least to greatest. If you're talking about decimals, I personally just think of it as money, right? So, for example, 0.25 is like 25 cents. That's like 27 cents. That's like 33 cents. What's this like? It's 30 cents, right? You can add a zero to the end if you like. So that's another strategy. If your decimals don't have the same number of places, you can always add zeros to the ends of decimals and it doesn't change anything. So in other words, I can write that 0.3 as 0.30. It's the same thing. So if I had decimals with 3 digits, I might add 0 so that they all have 3 digits, just to make it easier. I also personally sometimes like, these ones aren't too bad, but when they start getting really tricky, sometimes writing them vertically will help. So I might as well. What the hey? So I'm just going to write that. And then you just line up the decimal. And it makes it a little bit easier to sort of see who goes where.
That's why it's important to put the zeros there if you need to, right?
Mm-hmm.
Strategies.
What do I do with this 0.3 repeating? What's that really? What's 0.3 repeating? Hal?
0.33333.
Yeah, it just goes threes forever. So it's not the same as this one. Because this one is 3, 3, and then the next digit, if I went one more, wouldn't it be a 0? But 0.3 repeating is threes forever. So there's, I might even throw in another 3 just to remind myself. That one's just going to keep going. Threes, 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 forever and ever and ever. In fact, I'll even double remind myself that there's this, it just keeps going and going and going. So now let's talk about this like money. If I'm talking about cents and I want the least to greatest, what's the smallest amount here? Everybody. 25 cents, right? So that's got to be the least. 0.25 comes first. Then what will come next? 0.27. Do we all agree? Now you're thinking about money. 30 cents, 33 cents, or 33 cents and then threes forever, right? So who comes next out of these 3?
30.
Just 30. Now I'm down to these 2. This one?
Yeah.
I agree. Because remember, the next digit here would be a 0. So this one's smaller than that one, because this one, even though it never ends, it's going to be threes forever, and not, that one's just a 0. It's done. So this one comes next, oops, 0.33, and then 0.3 repeating would be my largest in this list. Evan? Oh, okay. That's all right. Does that kind of make sense? All right, let me ask you this question. Where would I put the number in this list if I had to stick in one more number and it was 0.27 repeating? Where would it go? In between what two numbers? Pablo?
I want to say like. I was thinking. Here.
Well, would it go right here?
Yeah.
Well, is it going to go over here?
That's what I. That's what I was.
Yeah, it's not going to go over here because I know it's 27 cents and then more, but it's not 28 cents yet, right? This is still less than 28 cents. Even though that 7's going to go on forever, it doesn't matter. It's still less than 28 cents. Because you're talking about fractions of a penny. So if you have 27 cents and then fractions of a penny forever, and I have 28 cents, I still have more than you do. Because I have one whole penny. You only have fractions of a penny. You get what I'm saying? Does that make sense? So, this is not bigger than 28 cents. But it is more than 27 cents. Because you have 27 cents and then a little bit more. So this one would stick right in there. Does that make sense? Huh, get it? Okay, let's try another one. Say I gave you these decimals. Okay. I know that's a bunch. Here, I would absolutely use those two strategies that we just talked about. Writing them vertically and I didn't do a repeating one. Oh my gosh, hold on. Put a bar over that. And you know what? This is Friday.
Wow.
Let's just go wild here. You didn't know that math class could be this fun. Okay, so let me help you get it started here. So first thing I'm going to do is I'm going to write them vertically and I'm going to line up those decimals. Some of you don't have the best handwriting. That's okay. But do your best to line up those decimals so they're, and see how I kind of did it here? They're all lined up. And then you kind of want to line up your first digit and line up your second digit because that's going to help you later on. So I'm going to line them up and I'm going to make it kind of going to help myself out. So first I'll just line them up. And then I'll worry about them all having the same number of digits. Okay, so there they are, all written vertically. Now I want them all to have the same number of decimal places. It makes it easier to sort of visualize. So I want everybody to have 3 decimal places, because that's the most I have. What number will go right here for this guy? If it's a 1, right? Because that's 1 repeating, so it's ones forever. So that would be a 1, and I'm going to kind of move my bar over here. You already have 3. What number will go right here? A 9, because that's 9 repeating, so it's 9s forever. What number would go here? 0. This is not repeating, so those are just zeros. And what number will go right there? 0, because again, those 9s are not repeating. There's no bar over it. Okay. Now, you start with your first number after the decimal. I want least to greatest, right? It's actually probably easiest to pick on my greatest right now. Which one has to be the greatest? Yeah, this last one. You start with your first digit. Okay, so this one's definitely my biggest. So I'll put that all the way over at the end, 0.99. So I'm done with that one. And then the second biggest would have to be which one? 0.1. So I already have the last two. These four are tied for smallest so far, because they all have 0 as the first number. So then I go to the second number, 0109. Okay, well, out of these four that are left, who's the biggest? Yeah, this one, because 9's the biggest second digit. So you are my next biggest number. So I'm kind of working backwards on this one, but that's okay. Oh. All right, so that one's done.
It's been off the screen.
Sorry. Yeah, this one has to be the next biggest, working my way down. 0.01 repeating. So now you're done. And now I have two. I just had to figure out who is the smallest out of these. So they're both tied in the second digit. They both have 0s. And then the third digit, I have a 1 and a 9. So 9's the next biggest. So 0.001 is the smallest in the whole set. And there is my list from least to greatest. So we actually showed a whole bunch of strategies in this one. Writing it vertically, having the same number of decimals. Sometimes it's easier to work from greatest to smallest than it is from least to greatest. Just depends on your number set. Okay, we're all right here? Next week we'll throw in negatives, and then we'll work on ordering negatives. But before class is over today, I want to talk about ordering fractions. And I'll give you a couple strategies to do that. And then we have a fun activity. Oh boy. Ordering fractions. Ordering fractions is easy when they all have the same denominator. Are they all going to have the same denominator? No, of course not. So let me just give you a random list of numbers and we'll talk about some strategies. How about a half, a fourth, maybe 7/9, and how about 3/10, something like that. So again, these are all positives. If you had positives and negatives mixed together, you know all the negatives are going to be smaller than all the positives, and then you would just have to order them there, but at least you have somewhere to start. Okay? So, again, we want to do least to greatest. Oh, you know what? I got to add one more to this. Sorry. I know. Let's add 5/4. So here is my helpful hint to you. I kind of look at my numbers and I want to decide if they're big fractions or little fractions. So for example, 7/9. 7/9 is pretty close to a whole, right? It's not quite there, but it's pretty close to 1. So this is kind of a big fraction. Look at 5/4. What's up with 5/4? It's bigger than 1 because that's an improper fraction. So right away, I already know who the biggest one is out of the whole group. It's got to be 5/4 because it's bigger than 1. All of these are less than 1. So I know that 5/4 has to be the biggest. Okay? And then I'm looking at okay, so that one's done. So now that I'm looking at these 4, that's a half. Is 1/4 bigger than a half or less than 1/2? Less, right? If you eat 1/4 of a pizza, that's eating less than 1/2 of a pizza. So that's still smaller. What about 3/10? Is that bigger than a half or smaller than a half? Smaller, because what is a half if the denominator is 10? 5. 5/10 would be half, so 3/10 has got to be less than that. So 7/9 is the only one that's bigger than a half. So it's got to be my next biggest. Oops. Okay, so now I'm looking at these three. You guys already told me that one. What'd you say? Oh, okay. Didn't you guys tell me that both of these were smaller than a half? So then, doesn't that mean that the half has to be my next biggest? So now, I'm just down to these two. Okay, so I haven't done any like crazy hard math yet, but now I gotta think about these two. 1/4 and 3/10. Yes.
Can you like see how many like 1 is to 4 and 3 is to 10, and then whatever like smaller number is, like the bigger it is?
Are you talking like something with cross multiplying?
No, so like if you do like
So let me write them over here. I'm comparing 1/4 and 3/10. And then, Miss Mosca, do you know this way? Because I don't really.
About the means and the, so you're talking about multiplying 1 times 10 to get 10.
no, I'm saying like
That
if
was another.
so like 2/4 is a half,
Yeah.
and because that's like bigger than 3/10, it can't be a half, but that makes one bigger.
No. But you touched on a method that does work. Miss Muska, can you explain? Because I don't really, I don't totally. Here's what my question. I know you can cross multiply them, but then how do you know? Isn't it like you have to write it up top?
Yeah.
Okay, so if I want to compare two fractions that don't have the same denominator, one thing you can do is multiply their diagonals. And what you do, so 4 times 3 gets me a 12. You write the answer up top like that. 10 times 1 gets me 10. Since 10 is smaller than 12, it means that this guy's bigger than that one. So that's one method. If you're just comparing two fractions, so if you're down to 2, you can multiply the diagonals, but you got to write the answer up top like this. And then 12 is bigger, so 3/10 must be bigger than 1/4.
That's real important, the direction that you're going.
Yeah. So start at the bottom and multiply up on both sides, and you can do that. Another thing you can do, depending on the fractions, is think about them as decimals. These aren't so bad. What's 1/4 as a decimal? 0.25. Yeah, so that's one that a lot of people know. And 3/10, you do know it whether you think you know it or not. What is 3/10 as a decimal?
0.30.
Yeah, it's literally 3/10. Right? Isn't that, I know we say 0.3 because we're being lazy, but remember the right way to say that number? Isn't it 3/10? Yeah, if your denominator is 10 or 100 or 1,000, when you read it, you're reading the decimal as well. It's the same thing. You say it the exact same way. So if you read this 3/10, you're like, oh yeah, 3/10, that's a decimal, 0.3. And then it's a little bit easier to order them in decimal. So that's nice when you know the decimals. Sometimes the decimals can be weird though, and you may not know what, like, I don't know what 13/15 is as a decimal. I have no idea. I could do out the long division, but that's probably going to take me more time and be super annoying. But I do know that 13/15 is awfully close to being one whole. So if I was ordering them, I might be able to sort of figure out its placement without figuring out its decimal. Does that make sense? Okay, so I have a little